Welcome back, section 2.2, algebra of functions. Today I want to focus in on composite functions and also look at some operations within those functions. Remember, your operations are like addition, subtraction, multiplication, division. We've talked about those quite extensively in the past, so we're going to refresh and put them all kind of maybe in one problem you might enjoy. So composite function, remember composite function, we're taking one function and plugging it in where the variable is on another function. So an example, if we have f of x as being 3x minus 2 and g of x being x squared minus 4, can we find f of g of x? And we may have seen this, some of you, as FOG of x or FOG. You may remember some of your teachers may be calling it. So this tells us that we're taking the g function and we're going to replace it into f where we see an x. So this notation, if you remember function notation, if I ask you to find f of 3, that asks us to take 3 and plug it in wherever we saw an x in the f function. With a composite, same thing. We're taking just now a function and replacing it for the x's in that f function. So instead of just replacing the x with a number, we're replacing it actually with an entire function. So f of g of x is going to tell us to take x squared minus 4, plug in where we see an x in our g function. So we're going to rewrite the f, 3, take the x out, and put in x squared minus 4, and then continue writing the function of f. So notice we could take this x squared minus 4 out, put an x back in, and we'd end up with the same function back. This we can go ahead and simplify just a little bit. We have 3x squared minus 12 minus 2. Adding like terms, we get 3x squared minus 14. And we're going to go ahead and leave it like that. Can we find g of f of x now? So this, notice we're written a little differently. Here we're taking the f function and plugging it in to the g function. So we're going to rewrite the g function, so we get x squared, which is going to be 3x minus 2 now. Again, we're taking that x out, putting 3x minus 2 in its place, and then we're going to continue writing the g function. Again, replacing the x's with the 3x minus 2. We can go ahead and clean this up. Multiplying that out, we get 9x squared minus 12x plus 4 minus 4. 4 and negative 4 are going to cancel, so we have 9x squared minus 12x. And that's going to be our answer. And lastly, for the composite here, excuse me, we have g of 2. So it's asking us to find g of 2 to start. So we can find that g of 2, hopefully pretty easily. Plug 2 in. We get 4 minus 4, which is 0. And then it's asking us to find g of 0. So if we replace that g of 2, we found that that was 0, so we're looking for g of 0. Well, g of 0 is going to be 0 minus 4, or negative 4. In example 2, we're going to be looking at kind of some operations with our functions. Hopefully we remember this beautiful function, the function notation f of a plus h minus f of a all over h. Yay! So what's this asking us to do? Well, we're going to find f of a plus h. How do I find that? Well, again, I'm taking the f function, replacing all the x's with a plus h. So I can write that f of a plus h is going to equal 2 times a plus h minus 5. Simplifying that, we get 2a plus 2h minus 5. That's going to be our f of a plus h, so I can go ahead and replace that with 2a plus 2h minus 5. Then it asks us to subtract off f of a. What can we find f of a? Again, it's asking us to take wherever we see an x, replace it with an a in the f function. So we have 2 times a minus 5. And I'm going to subtract that off of this f of a plus h. So I'm going to subtract 2a minus 5. Be very careful that we put this quantity, or this expression in parentheses, because you're going to have to distribute this negative through when we go ahead and simplify. Then we're asking us to divide by h. So I'm going to go ahead and multiply that negative through and clean this up a little bit. So we have 2a plus 2h minus 5 minus 2a plus 5 over h. And something that's going to happen with all of these problems in this form. we're going to see that if it doesn't have an h in a numerator, then the terms should cancel each other out. So we see a 2a and a negative 2a, they're going to cancel. A negative 5 and a positive 5 is going to cancel. And we're left with that 2h. So we're going to be left with, running out of room, we have 2h divided by h. And now we can go ahead and simplify h divided by h. We can cancel those out. So 2h divided by h gives us 2. And that's going to be the simplified form of this. We won't always get to a single number, to a constant, but we're going to see some things that are going to happen quite constantly with these functions. So let's go ahead and look at example 3 here. A little more complicated, but we can do it. Again, we're going to find f of a plus h. To do that, we're going to plug in our a plus h for our x's. So f of a plus h is going to equal 2 times a plus h squared minus 4 times a plus h plus 3. And I want to go ahead and simplify this. I'm going to square out my a plus h. So that gives me a squared plus 2ah plus h squared. I can distribute my 4, so negative 4a minus 4h plus 3. If you had trouble with this a plus h squared, you may have to come up to the top here, off to the side, and write 2 of them, and then go and distribute your a, distribute your h. So we get a squared plus ah plus ha plus h squared. These two middle terms are the same, so we can go ahead and add those together. 1 plus 1 gives us our 2, if you need to. We're going to see this quite extensively again, so you may want to remember that a plus h squared is a squared plus 2ah plus h squared. Distributing the 2 there, we get 2a squared plus 4ah plus 2h squared minus 4a minus 4h plus 3. And then we can go ahead and find our f of a. That's as simplified as we can get as well. So f of a, replace our x's with a's, so we get 2a squared minus 4a plus 3. So now we're going to take this expression of f of a plus h and subtract off of it f of a. It's going to be on the lengthy side, but again, not too miserable, I don't think, for us to do it. Remember to put f of a in parentheses because we're going to distribute that negative. Very important that we distribute that negative. So if I distribute that negative, just a lot of writing here, isn't there? 2a squared plus 2ah plus 2h squared minus 4a minus 4h plus 3. That was my f of a plus h. Distribute my negative. I get 2a squared plus 4a minus 3 all over h. So as I look at my numerator here, I can go ahead and cancel out a 2a squared, I can cancel out a 4a, I can cancel out a 3. So I'm left with 4ah plus 2h squared minus 4h all over h. Notice my numerator, I can factor out an h. I'm going to run out a little bit of room again, so we get 4a plus 2h minus 4 all over h. I can cancel out my h's, so I end up with 4a plus 2h minus 4. And that gives us another example of, or another simplified form of the f of a plus h minus f of a over h. And I just did think of one problem. We probably need to do a fraction. You're probably not going to be too happy if I don't do a fraction. So let's do it and do f of x, maybe 1 over x. And if I ask you to find f of a plus h minus f of a over h, well, again, we can find our f of a plus h. That's going to be 1 over a plus h. And f of a is 1 over a. So I have 1 over a plus h minus 1 over a all over h. Oh, yuck, a complex rational. Good thing we did those at the beginning of the year, huh? So we can go ahead and find a common denominator for the numerator here, which is going to be a times a plus h. Remember, we can't just add on an h. It's got to be through multiplication that we find our common denominator. So our first term is going to need an a. Our second term is going to need an a plus h. Again, that's all over h. We can go ahead and distribute a negative through that. Notice our a's are going to cancel, and we're going to be left with a negative h on the top. So we have negative h over a times a plus h, and that's all over h over 1. We can make that h a fraction as putting it over a 1. This gives us a fraction over a fraction, so I can multiply by the reciprocal. So I get 1 over h is what I'm multiplying it by. So my h's are going to cancel. So my simplified form that I want to get to is negative 1 over a times a plus h. And that would be an example of an expression that has a fraction in it. Good luck today.